Alright, so 7-4, again, doing practice examples, mixed examples of basic probabilities. Alright, this is page 2 of the 7-4 notes. Alright, so problem number 3. The Tri-City Council contains 6 members from City A, 4 members from City B, 3 members from City C. An executive committee of 5 people will be randomly chosen to form a council. Alright, as soon as you see that term committee, it should be automatic at this point. Combinations. And we're going to pick 5. Alright, first probability. Probability that a 5-person committee will contain exactly 2 members from City A. So we want 2 members from A. Now there's a hidden and statement. Right, when I go to count this, the number of ways to get 2 people from A, well, I've got to pick 5, right? If I only pick 2 people from A, I'm missing out on filling out my group of 5. So there's the and statement. I need 3 others. And the others meaning other than people from City A, so they've got to be from B and C. All over my universal set. Which my universal set can be, I can pick up from any of the cities. Any person on the council can be selected. And then I write out my combination. So the first one is combination. I'm selecting 2 people from the 6 in City A, and so we multiply 3 people from the 7, right? 4 from B, 3 from C, so 7 others, right? Other than City A. All over the universal set, which means I pick 5 of any of them. All right, 6 and 7 meaning there were 13 people I could have chosen from, so 5 choose 13 would be the universal set. And then you plug them in the calculator. Alright, so 5 choose 13 would be 1287. That's an 8 if you can't read that. And then up top, 6 choose 2 is 15 times 7 choose 3, which is 35. And again, if you plug this all in one shot, that's fine. Just make sure you're careful. Multiply, then divide. I usually simplify my numerator and then do my division, so I'll take my 15 times my 35, which comes out to 525, all over 1287, and then I find my decimal approximation, which I'm just going to round 4 decimal places, 0.0479. Alright, make sure you're careful. Alright, don't round until the end, because you could be significantly off, especially when you're plugging things into the computer program. You don't want to be off. And make sure you're careful when they ask you to round 2 decimal places, 3 decimal places, 4 decimal places. Follow the directions and round appropriately. Alright, the second part of this problem, part B, so we're still picking a 5-person committee, but this time we want a committee that contains at most 1 member from City C. Remember, at most 1 member from City C means 1 or fewer. So if I pick 1 member from City C, or no members from C. So up top would be the number of ways to get 1 member from C. Remember, I have to finish my committee. So there's a hidden and statement. I need 4 others, right? Other than from City C, which means they need to come from A or B. Or there's nobody from City C, so no C people. That means I want all 5 others. Right, divided by the same universal set. Alright, so the universal set's still 13 choose 5. Up top, combination, I'm going to select 1 of the 3 people from City C. And so we multiply 4 of the 10 people from City A. Remember, City A had 6, City B had 4, so there were 10 people I could choose from. 6 plus 4 is 10. Or, so we add the case where we get nobody from City C. That means all 5 were chosen from the 10 from A or B. Alright, then you type that out on the calculator. So the denominator is still that 1287. Up top, 3 choose 1 is 3, 10 choose 4 is 210, plus 10 choose 5, which is 252. Now, again, you can type this all out on the calculator. Just make sure you're careful that you follow order of operations. The numerator has to be done first before you do the division. So that's why I usually simplify the numerator. So I'm going to go ahead and multiply 3 times 210, add my 252 to come out to 882 over my 1287, and then I do my decimal approximation. And so when you type that out, I'm just going to round 4 decimal places. 0.6 6853. 6853 is the probability, so about a 68.5% chance that if we randomly select people from the council, there's about a 68.5% chance that you'll get a committee with at most one member from City C, so one or none. All right, the next example. The probability that a school-aged child will get strep throat is 0.1, so a 10% chance. Probability he or she will get an ear infection is 0.12, 12% chance. Probability that he or she will get both, 0.07. Find the probability the child will get neither strep nor throat. So there's two ways to do this. You can either set up the Venn diagram or use the formula. So I'm going to do the Venn case and then I'll talk about the formula. So if I set this up with a Venn, right, because I know I'm looking for the outside area. This would be all kids. Right, which again, I think it's easier as a percent because we think about all kids, 100% of the school-aged kids. These are the ones that are going to get strep. These are the ones that are going to get the ear infection. And so they're both, probably they would get both. Well, that is a 0.07, so that's a 7% chance. 7% chance they get both. There's a 10% chance they get strep, so this circle should represent 10% of the school-aged children. I've already counted 7% of them, so that leaves 3 that will only get strep. Then 12% will get ear infections. Well, we've already counted 7% of those who also got strep, which leaves 12 minus 7, so 5% over here who only get ear infections. Right, this is actually the area I want to find. That's the probability a child will get neither one of those infections. And so it's the outside area I'm looking for. Well, I add those up, so I'll take my 3 and 7, which is 10, plus 5 is 15. And so that means 85% of school-aged children don't get either one of those. And so the answer is probability that they get neither strep or an ear infection is 0.85. That's using the Venn diagram. Now, you could have used the formulas. If you did use the formulas, you'd have to use two formulas. Right? Because I want to know the probability. So suppose I let, strep be ST and ear infection be EI. So I want the probability that we don't get strep and an ear infection, right? We get neither strep nor an ear infection, so we're not getting neither strep or an ear infection. And so what you could have done is you could have found the probability of getting a strep or an ear infection and then use the complement, which would be probability you get strep plus the probability, I'm going to run out of room, so I'm going to write it below. Probability they got strep plus the probability they got an ear infection minus the probability they got both, which would be our 0.1 plus our 0.12 minus our 0.07. Alright, this would come out, excuse me. Alright, so we get 0.15, which is not the answer, right? I want those, that was the 15% who get one or the other. I would want the complement to that, so I take 1 minus our 0.15, and I get the same answer. So you could use the formulas if you wanted to. I personally think the Venn diagram is the easier way to go in this case, right? But there's nothing wrong with using the formulas too. You'd have to use the OR formula and then the complement of the OR is what we're looking for. All right, so the complement of not getting strep or the ear infection. All right, the last one on this page, all right, so this is where the video will stop here, and then I'll pick up the next page on the next video. Alright, so a disciplinary board at the university consists of 6 faculty members, 2 administrators, and a single student. A board must randomly select 2 different people to fill the positions of chair and assistant chair. What's the probability? Both positions will be filled by faculty members. Alright, well, I'm picking 2 different people, so that means no repeats. I'm filling different positions. Right? Unlike the committee example, where they would all be on the committee and all have the same position. They're all committee members. This one there's a distinction, right? There's the chair, which I would assume had more responsibility, then the assistant chair, the person who assists the chairperson. And so order matters, which means this is a permutations case, not a combinations. All right, so we're looking for, so there's the what we pick out from the problem. So we want the probability that we fill both positions with faculty. Well, it would be the number of ways to fill in two positions with faculty. You can read that. Two positions with faculty, if you can't read that, over my universal set, filling out the position with anybody. They could be anybody, faculty, administrator, or the student. Well, you could use permutations if you want to, and I'll set it up both ways. All right, so if you use permutations, the denominator would be I'm filling two different positions, so they're choosing two people out of anybody, right? My universal set would be anybody. So how many anybodies do I have? I've got 9 anybody's. So I could do permutation. Out of 9 people, I'm filling two positions. All right, up top is the event where I'm going to fill both positions by just faculty members. So this time in my event, I'm only picking faculty, which there are 6 of those. So it'd be permutation 6, choose 2. And that's fine. You can plug them in the calculator and go. An alternative to this, remember with permutations, I could use the subtraction case. Alright, so the universal set would be I would fill two positions with anybody, and so the first position, the chair position, there would have been 9 people to select from. Fill the chair. 8 left over for the assistant chair. Right, that would be the universal case. Up top is I'm filling them with just faculty, so the first position would be filled by a faculty member, and there would be 6 of them to choose the chair. I pick the chair, which means there would be 5 left over to fill in the assistant chair. Right, and so when you multiply those out, that comes out to 30, right? 6 times 5 is 30 over 72. So there's 72 different ways to do it. 30 of them are filled by faculty members. Right? And then you find the decimal approximation, which is 41.6 repeating. So I'm going to round to 41.67. So there's about a 41 or almost a 42% chance that if we randomly fill the positions, both of them will be filled by faculty members. Right? There's 30 chances out of 72. Alright, so again, I'm going to stop this here. I'll pick up the next page of notes in the next video.